Okay. So this is, you want to turn in your homework to this guy right here. Okay, make sure you're on this page right here. Okay. So we're going to do a couple problems together. We're going to give you time to work. Today you want to determine a derivative, an official derivative. It's a big day for you. And we're going to use this beast, the limit as h goes to 0 of f of a plus h minus f of a all over h. And the good thing is that you saw this back when you were in 9th grade, not quite, 11th grade. So we did this last year. Okay, did this last year, and so you're good to go. Okay. What's that? No, but we did that. So the really, kind of one of the only things that's different about this year is that you now have a limit in front of it. See what I'm saying? All right. So let's do this one together, okay? What we want to do is take this curve, x squared plus 3x minus 4, and we want to find the derivative at x equals negative 2. So we are saying that a is equal to negative 2. That's our a value, okay? And you have to get used to plugging this in properly. So I made a little bit of a graphic organizer. If you don't want to use it that way, then that's fine. But if a is negative 2, then I'm going to write a plus h. So it would be negative 2 plus h. Can somebody think of a different way to write it other than negative 2 plus h? H minus 2, that's how I would probably choose to write it. Okay? Everybody see it? That's a plus h. Then f of a plus h, we take that and we plug it in for x. And so we get h minus 2 quantity squared plus 3 times h minus 2 minus 4. Shh, pause. Does everybody see where I got that? Yes. Do you see how I got this? Okay, I take this and I plug it in where I have an x. So h minus 2 squared plus 3 times h minus 2 minus 4. Better? Yep. And now I need to determine f of a. So I got to plug negative 2 in. You guys help me out. What's negative 2 squared? 4. And then I have plus 3 times negative 2. What's 3 times negative 2? So it's a minus 6. And then minus 4. What is 4 minus 6 minus 4? So I'm taking negative 2 and I'm plugging it into the function. Negative 6. Okay. Now we are able to write the formal definition of the limit, of the derivative. The limit as h goes to 0 of, this is f of a plus h. Have we already determined f of a plus h? Yes, it's this thing right here, isn't it? And so you write it out. H minus 2 quantity squared plus 3 times h minus 2, then what? Minus 4. What does it say after that? It says minus f of a. So plus 6. All divided by h. So that's what we want to simplify. And when we simplify it, we will get the derivative. So this is the space I intended for you to then be able to work the limit as h goes to 0 of h minus 2 quantity squared. Help me out. H squared minus 4h plus 4 plus 3h minus 6 plus 2 all over h. Could you combine some like terms? Yeah, you have the limit as h goes to 0 of, we just have h squared. Then what do we have? Minus h And then those are all gone, right? The 4, the 2, and the negative 6 go away, divided by h. Factor out an h, the limit as h goes to 0 of what happens? Can I now plug in 0? What do you get when you plug in 0? Negative 1. Now, a couple things to see if we understand the full picture. Does anybody know what would I have gotten if I plugged in 0 right at the beginning? 0 over 0. Yeah, that's what you've got in the beginning. Excellent. I'm going to show you how to check your answers. Something super cool. Take out your calculator. We'll go back. Let's do this first. Here we go. I'm going to plug in x squared. I'm going to do a plus 3x. And I'm going to do a minus 4. Now, before to check our answers, we actually had to graph a tangent line, didn't we? We're going to show you that you don't actually have to do that. It's still a cool thing to do, but in this situation, there's something else you can do, and it's really neat. I'm going to press Zoom 6 for Zoom Standard, and everybody should get a nice-looking parabola. Everybody have that? Okay. Now, it says that we're finding the derivative at negative 2. So if I go back 1, 2, you can see here, you know, who knows what the slope is at that spot. There's an option on your calculator that shows you the slope, which is really cool. Second, calculate. Now, in this class, last year, we actually talked about value, we talked about 0, we talked about min, we talked about max, we talked about intersect. Numbers 6 and 7 are reserved for just calculus topics. And this says the dy over dx, which means the change in y over the change in x, which is the derivative. It's your slope. So if you just simply press 6, it's going to find the derivative at whatever point you choose. And what is the point we're going for? If I just type in negative 2 and press enter, it tells me that dy over dx, so the derivative is exactly negative 1. Because I can teach Tenley how to do this, right? I can teach my 6th grader how to do that. I can't teach my 6th grader how to do that. That's not calculus. This is the calculus. Yeah. Or when they all know calculus, right? Yeah.
I could teach my dog how to do it.
Oh, wow, you could. That's impressive.
I was saying, like, that's like the next.
All right, flip it over. Look at number 8. I'd like to do 2 more with you, give you some time to work. Number 8, okay? You guys tell me what's different about this one. There's a radical. No big deal for us because we're really smart. What's the value we're finding the derivative at? 4. So 4 is a. So I have 4 plus h. Everybody okay with 4 plus h? So then f of 4 plus h, what would it be? Good. You okay with that? Okay, f of a. What do I do for f of a? I plug in. When you plug in 4, you get square root of 4 is 2 minus 3 is negative 1. Good. So we're going to set up the limit. The limit as h goes to 0 because this is what the derivative is equal to. So f prime of 4 is equal to this guy. Okay, so the derivative at 4 is equal to that. And what is f of a plus h? Minus So plus 1 over h. Great. So I have the limit as h goes to 0 of the root of 4 plus h. Then what? Minus 2 over h. Did we take some time in the last unit to work on solving those limits?
Yeah.
That was so you could have success today and not be confused with it. Okay, so I'm trying to scaffold what we're doing so we can have success. What do? Yeah. We do Spanish, multiply by the conjugate. Man, you guys are smart. Thank you. Limit as h goes to 0. So we've done this before. This should be kind of routine for us to some degree. What do we get when we multiply those square roots? 4 plus h. And then the middles go away and we get a minus 4. And in the denominator you have okay, so careful as we talk about canceling out. I want to show you the work that I would like to see at this point, okay? So I'll take it easy on you guys. You don't have to necessarily write the next step. I will allow you to say, hey, what's going to happen to the 4s? They cancel, and then the h's cancel, so you're left with 1 on top. Please make sure you at least write a 1 on top so I know what the heck you're doing. Get my point? So can I now plug in 0? What do you get on the top? 1. In the bottom, when we plug in 0, we get 4 plus 0 is 4. Square root is 2 plus 2 is 1/4. And if you wanted to type that into your calculator and check it, you could. Okay, let's go to Ella's question. Thank you for asking. If I go to y equals and I type in the original function, Ella, what was the original function? Square root of x, parenthesis, and then minus 3. Tell me when I can go. Second, calculate. Number 6. What is the value that I'm finding the derivative at? 4. I press 4 and I get 0.25. I type in 4. Presume 6 and you should get back to a good spot. What's that? I don't, I'm sorry. Okay, flip it over. Last one. Let's do number 12 together, okay? A is 3. So what is this? 3 plus h. What do you get when you plug 3 plus h into the function? Yeah, so I'm going to kind of pair your guys' thoughts together. I get 1 over the 3 plus h minus 2, and you see that that is 1 over h plus 1. So if you want to use some space to simplify, go ahead. Again, I told you that the algebra would come. This is the algebra focus. F of a, we plug in what? 3 and you get 1. So that means that f prime of 3, so the derivative at 3 is equal to the limit as h goes to 0 of what? Good, 1 over h plus 1? Minus 1 all over h. Good, so you have a complex fraction. So these are the 3 scenarios: polynomials, radicals, and then complex fractions. Those are the three that cause the issues, folks, okay? Those are the three. So I should say cause issues. Those are the three examples that we'll talk about. And that's what we'll be limited to on your test. So Ella, if we have a complex fraction, what do you do here? H plus 1 over H plus 1. Excellent. So I have the limit as H goes to 0 of 1 minus H minus 1. It's so important that you remember to distribute the subtraction sign. It's the biggest mistake that's made in this. Over H plus 1 over H over 1. I personally would prefer that you not just crisscross and cancel at this stage. I prefer that you actually write out this next step, because what do you get in the top? Negative H over H plus 1. And instead of dividing by H over 1, I will multiply by the reciprocal. And it's 1 over H. So now we cancel. Can I now plug in 0? And what do you get? Negative 1. That's your derivative. Now, suppose that Michaela, okay, she doesn't have her calculator, or she doesn't want to go to it. She doesn't have enough time to type it in, but she's trying to check the reasonableness of her solution. Michaela, do you know what that graph looks like? Yeah, it's shifted to the right. How many units? And so you know that it looks like this, agreed? So if you're finding the derivative at 3, does it look reasonable that it could be negative 1? Yes. Again, the more ways you could think about the nature of the function, it can help you verify and see if you've done anything wrong. So usually what I do is I do the 3 problems in the notes, and then you guys go to work on the homework. But you already have 3 problems done. And you can cross any 2 off from that set as well. So there's a total of 16 problems. We did 3. You get to cross off 2 more. That means a total of 11. Go. Your time to work and ask questions.